Hi everyone, today in Integrated Math 2, we're going to go over Chapter 13, Lesson 2. Here are the objectives. Make sure you write them down in your notes. Alright, so let's go over factorials. A factorial is a positive integer n written as n factorial. And as you see, it looks like an exclamation point. Is the product of the positive integers less than or equal to n? So n factorial is equal to n times n minus 1 times n minus 2, continues, 2 times 1. And 0 factorial is always 1. So let's say that I have 5 factorial. What this is saying is it would be 5 times 4 times 3 times 2 times 1. So I have 5 times 2 times 3 times 2 times 1, which would end up giving us 120. So as you see, it just continues. If I was to have, let's say, 6 factorial, we would do 6 times 5 times 4 times 3 times 2 times 1. And that's just a simpler way of writing it so that you don't have to have all these numbers. You just say 6 factorial or 5 factorial. Alright, next we have permutations. So the number of permutations of n distinct objects taken R at a time is denoted by NPR and given by n factorial divided by n minus r factorial. So as you can see here, we have 5 factorial, and then we have 5 minus 2 factorial. So if you want to see this expanded out, I'd have 5 times 4 times 3 times 2 times 1. And then I have 5 minus 2 factorial, which is 3 factorial, which is 3 times 2 times 1. So what happens is like the 1's go away, 2 divided by 2 is 1, 3 divided by 3 is 1, and then I'm left with 5 times 4, which is 20. That's where that's coming from. So permutations with repetition. The number of distinguishable permutations n objects in which one object is repeated r sub 1 times another is repeated r sub 2 times, and so on is n factorial times r factorial, r sub 1 factorial times r sub 2 factorial, and continues to r sub k factorial. You can still reduce just like as we did previously in canceling out with what we can. Alright, so in circular permutation, objects are arranged in a circle or a loop like we have here. It's like a lazy Susan that you can spin around. So notice over here we're turning it clockwise. One position does not produce a different permutation. So what I'm saying by this is just because you're turning it doesn't mean that now we have 2 salts. We still have, in our case, lime, curry, salt, pepper, and ginger. It's just in a different, it's just rotated. So since the 5 rotations of a turntable will produce the same permutation, still same amount of outcomes, the number of distinct permutations on the turntable is 1/5, which means if you choose one, you have 1 in 5 chance of, let's say, choosing salt. If you were to choose one randomly, because there's 5 choices, and you're only choosing 1. So you have a 1 in 5 chance of choosing whatever you desire. And we're going to times that by 5 factorial. And this is going to reduce to 4 factorial. So circular permutations, just like we were talking about, is a number of distinguishable multiple permutations of n objects arranged in a circle with no fixed reference point. So not anything specifically to reference towards, we could just randomly grab one. So n factorial divided by n, or n minus 1 factorial, which is exactly what we just talked about in the last slide. Probability using combinations. A combination is an arrangement of objects in which the order is not important. So, as you can see, we have our combinations of socks, and we can have all these different possible combinations because the order does not matter. Like we have like the diamond socks and the purple and blue and red socks, and notice the order changes throughout. But that didn't matter because we didn't need a specific combination. Alright, so combinations. The number of combinations of n distinct objects is taken r at a time and denoted NCR, and can be divided by n factorial divided by n minus r factorial times r factorial. So the number of combinations of 8 objects taken 3 at a time. So we have the 8 and the 3 between the C. So 8 factorial divided by 8 minus 3 factorial times 3 factorial. And notice here we had like the 5 factorial both canceled out. They're both the same, so you can do that. So you also don't have to write 5 times 4 times 3 times 2 times 1, and same thing on the bottom as well. That's just another shortcut. And there we go.